The next time you're at a party or a social gathering and you have nothing to say, pose this question as a logic riddle and you will be surprised at how much interest this question will arise. Why? Because in my opinion, it explains in the best way possible just how much we don't understand probability. So let's start. Approximately 0.01% of men aged 40 to 60 have prostate cancer. A man with prostate cancer has 99% chance of a positive test from a PSA blood test, while a man without prostate cancer has only 1% chance of a false positive result. What is the probability a man has prostate cancer given that he has just had a positive test? So let's define the terms. H means he has cancer. E, or the evidence, means the blood test was positive. So according to the test, he has cancer. We want to calculate P of H given E, the probability that he has cancer given that the test came out positive. Again, if the test is 100% accurate, no false positive, if the test came out positive, then we know for a fact that he has cancer. But the test is not 100% accurate, and therefore we don't know for sure he is sick. So Bayes' law says the following thing. P of H given E equals P of E given H times P of H divided by P of E. So let's start with the likelihood because it is the easiest to calculate. P of E given H. Let's assume that I know I'm sick, yes? The hypothesis is correct. What is the chance that the test will be positive? This we can get from the question. The test accuracy is 99% in each direction. This means that out of 100 sick people, the test will assign 99 of them as sick and just one as being falsely healthy. Let's go to the second part. What is P of H? P of H is a prior chance that a person is sick. Now, how do I know what is a prior probability that a man is sick? I get it from the statistics, the distribution of the disease in the population. The prior probability that a man is sick is how common the disease is in the population. And again, we also get it from the question. 0.01% of all relevant men are sick. So the prior probability that a man is sick is 0.01% or 1 divided by 10,000. Now we are ready for P of E, which is the most complex one. So what is P of E? What are the chances that a PSA test will come out positive? But it is important to know that the PSA test can be positive in two different ways. The man may be sick or healthy. When he is healthy and the test is wrong, we will get a positive result. When the man is sick and the test is correct, we will also get a positive result. So we need to apply the rule of total probability. Since the events healthy and sick are mutually exclusive and exhaustive, we can write P of E as the following. The probability that the test is positive given that the man is sick times the prior probability that the man is sick plus the probability that the test is positive given that the man is healthy times the prior probability that the man is healthy. If we inject the number here, we get 0.99, which is the likelihood, times 1 divided by 10,000, which is the prior probability that the man is sick, plus 0.01 times 9999 divided by 10,000, which is a prior probability that the man is healthy, which equals 0.010098. So back to Bayes' law, the posterior probability is 0.99 times 10 to the minus 4 divided by this, which is 0.0098, which is approximately 1%. And this is incredible. This is so profound that we need to state it over and over again. Although the test is accurate in 99%, the posterior probability that the man is sick is less than 1%. Why? Because we need to take into account the prior probability of the disease in the population. In other words, it is more likely that a healthy man was randomly chosen and the test was wrong than a sick man was randomly chosen and the test got it right. What happens if we test the man twice and the tests are independent? Now the new prior probability will be this, 1%, no 0.01%. So please try to solve the problems below to make sure that you have a good understanding of this important law. Good luck.